So we have made some modification in our application, and we're going to see from that we can find anything extra from our Wireshark. So let's continue our Wireshark journey. So our setup is pretty same, no changes. All I have done is I have added this socket close. I'm doing the same thing in the server as well. In line number 11, I'm just closing the socket. One thing to notice here is that I'm not closing the listening socket on the server. So there are two sockets. One is the listening socket, which we are creating here, and the one we are getting from the accept. If you want, you can close this socket as well. No big deal. But for our purpose, this is a guy which throws data into the network. For the time being, we are bothered only about this connection right here. Now what I'm going to do is I'm going to put a breakpoint on line number 11 and line number 12 in the case of client. So we have breakpoints here, and we have the same Wireshark started. Everything's same. We are listening on the loopback adapter of the system, which is where our application going to send packets to. And we have a display filter in the Wireshark as given like this. TCP port equal to 65432. All exactly same as the previous session we had. No changes there. Now I'm going to run the server. Now the server is listening. So it is waiting on line number 7. We know that. We have seen all this before. Again, I'm going to start the client. So the server has come up to line number 11, and so do the client. Now let's look at the traffic. So we have the SYN/SYN/ACK ACK here, which is the three-way handshake, whatever we discussed, not in detail, but these are the 3 packets created by the connection call. Now we are sending data here. We can see the data packets right here. If you look, this is a binary information right here, and the binary is equal to hello world, which is the data we are sending. This is the acknowledgement for that same thing. Again, server is sending data back. We have seen all this before, and the acknowledgement from the client to the server. Now we are not seeing the FIN packets. We are to see the FIN packets. So where is it? That is where this close is going to do. So let's execute the close. So what I'm going to do is I'm going to do the close from the client. I have done the close from the client. So you got a FIN and FIN/ACK. So the FIN is here. So it has finalized, telling the server, hey, I'm done with the connection. Close the connection. And server is acknowledging for that. And if you look here on the server, if I do this, again, I'll get a FIN/ACK like this. So this FIN/ACK is from the server corresponding to the close connection. So FIN/ACK is a graceful termination of a connection. So both parties gracefully terminating connection. We will discuss more about a reset, which is not a graceful termination, at least not as good as FIN/ACK. We will see that. But before that, let's have a quick look at what we have learned so far, or what we have observed so far. We have not learned anything much so far, at least. We don't know what's going on. So what we would like to do right now is we need to understand what is being happening at each line of this particular program. Remember, our original goal is to understand this program right here. These few lines, that's what we are trying to dig using different tools. Now we have the accept. So this accept and the connect on the client. These lines create those 3 packets right here, SYN, SYN/ACK, and ACK. Those are the 3 packets these lines throwing into the network, or that is the data which is transferred from the client and server when we do a connect and accept. So let's see that again. So SYN, SYN/ACK, ACK, 3 packets. So what is the data inside that? This is the data inside that. This is a binary ones and zeros, putting it into the network, or any device for that matter, or the data which is communicated between the client and server. It could be network, it could be anything. In this case, it's not even network. It is just a loopback adapter. So there is no networking here yet, because it's all running inside the same computer. It's using the loopback adapter. But still, all the concepts remain same. So all we know is this is the data. This is the binary information shuttling between the client and server when it's doing a connect and accept. 3 packets, packet number 1, 2, and 3. As you can see, when I select, the data here is changing because the information inside this is changing. So what is a packet? Every line inside the Wireshark is a packet right here. Each line is a packet. What is a packet? Packet is nothing but just a chunk of data. Ones and zeros. Everything is ones and zeros. In our world, everything is ones and zeros. We have seen that throughout all our previous trainings. And these are the ones and zeros transferred in this packet, and these are the ones in this packet and this packet. You will see a lot of similarity between them. We'll understand what is similarity and what is its numbers. That is all this training is all about, to understand these numbers one way or the other. But for the time being, the connect and accept is generating these 3 packets. That's the important fact we are trying to understand or trying to by heart. I wouldn't use the word understand. I would use the word trying to know. Now, what is next? We have send from the client and we have send from the server. These 2 sends are generating these 4 packets. The first send is creating hello world. It is sending hello world, and this is the acknowledgement from the server for that hello world. Hey, I received hello world from you. Everything is good. It is safe with me. That is this packet is all about. Now, after that, the server is sending its own data, hello world from server, and the client is acknowledging that. Now, after that, we are sending fin and finac. Again, there is no data associated with it. It is all control packets or TCP state machine packets. What is this packet for? In this packet, the client is telling, hey server, I'm done with the business. Please close the connection. I'm not interested in sending further packet on this particular connection. If I want to send more packets, I will create a new connection. Please terminate this in a very nice, friendly way. So that's where finac comes, and then server is saying, hey mate, we are good, let's end it. Then server is saying, hey, I'm also closing the connection, and client is acknowledging for that. So feel free to click through these packets if you're doing this demo by yourself and see the data here changing, because each time it is different data for each packet. A packet is nothing but a chunk of information sent between client and server. How do you differentiate between client and server in this case? In a proper networking scenario, the IP addresses will be different, but in this case, the IP addresses are same. No problem, we use the port address. Whenever 65432, that is our server port. Any packet coming from server. So this is coming from server to, look at this arrow right here, to client. In this case, it is 52431. This number is always a random number, but once in a connection, that number is same. So this is same number throughout this connection. But for a new connection, that number will change. But this number 65432, that number is not going to change. That is a standard number taken from our code. Very important point. This is sent from client to server. This is server to client, client to server, client to server, server to client, like so. Everything. So this is how you look at a network trace, the source and destination. It is much easier in the case of a different IP address. We will see that in future sessions, but for the time being, we have same IP addresses. Now we have also discussed this particular line is causing that fin, ac, and ac. So this is the server sending to the client, and this is client sending to the server to end the connection. So feel free to try to do this demo by yourself and play around it just to see the packets flowing through the network. Next, what I would like to show you is how the trace looks, the Wireshark trace or network capture looks when the termination is not graceful. So this is a very graceful termination. What if I kill this process before this? What happens? What if I kill the server before closing the connection or in between? That's what we are going to see next. So to conclude, we have seen how graceful termination works in networking. We have seen some extra packets, kind of a formal buy from one side. It is always not the case. Let's see when that doesn't happen. That's what we are going to see next.